Hello, it's Mrs. Pound, and I'm back with more about the structure of the Earth in Chapter 1.4. Last time we took a look at the core in the last video, and this time we're going to take a look at the next layer up from the center of the Earth, and that is the mantle in Section 1.4.2. So our objectives are to describe the separate sections of the mantle, including the asthenosphere, explain what convection currents are and how they are created, and to compare and contrast direct observations with indirect observations. So when we take a look at the mantle, this is the portion of the Earth's interior that extends from the outer core to the bottom of the crust. So if we were to take a look at this apple, this is the core. Just outside of that is the mantle. And just like with an apple, we can see that the mantle is most of the volume, and actually the crust would be just like the peel, very thin on the outside of that apple. In the crust, in the mantle, there are convection currents going on. These are the circular movement of heated materials to a cooler area and cooled materials to a warmer area. They are caused by extreme temperature differences in the mantle. The bottom of the mantle is very hot, and the top of the mantle is much cooler. This is actually really important that we have that buffer zone between the core and the crust called the mantle, because if we didn't, it would be too hot for us to touch. It would actually burn us up. The gases in the lower mantle heat up, expand, and rise. As they reach the upper mantle, they begin to cool down, condense, and sink. And so that causes this circular movement that is a convection current. And this cycle happens continuously. I want to go to our reference tables. So here's our reference tables, and there is actually a picture of these convection currents going on right here. We see that these convection currents are mostly happening in the asthenosphere, somewhat in the stiffer mantle, but the stiffer mantle is a little bit more solid. As we can see down here, the melting point is up here and the temperature is down here, so that's a little more solid. It's in this asthenosphere where we get a lot of this movement of these convection currents because it's partially melted. It's just below, the melting point is just below that interior temperature, and so it acts like putty and it's able to move very slowly. About as fast as your fingernails grow. So we have this rising over and then dropping and cooling. And these convection currents are, we're going to talk about this in future chapters, they have a role in spreading the continents apart. They have a role in crust movement. There's crust movement. They have a role in volcanoes and also in earthquakes because of these convection currents going on. So there's this circular motion going on in the mantle. Okay, so the mantle is pretty complex. And because of the complexity, it is divided into the lower mantle, the transition zone, and the upper mantle. So there are different zones in the mantle. And a special part of the mantle is called the asthenosphere. This is the layer of the upper mantle composed of low-density rock material that is semi-plastic like putty. This is where those convection currents are going on. Let me go back to our reference tables. So this is the asthenosphere right here, a pretty thin layer, and they even call it here in your reference tables the plastic mantle because it is kind of soft like putty, moving, like I said, about the rate that your fingernails grow. So very, very slow, but there is movement there. Above the asthenosphere and above the mantle, and part of the mantle and also part of the crust, is the lithosphere. This is the outermost rigid layer of the Earth composed of the stiff upper layer of the mantle and the crust. So the lithosphere, now lithification, remember, was the process of creating sedimentary rock. So basically, lith means rock, okay? And we can see that on our reference tables in the diagram. The lithosphere is up here, and they even have brackets around it showing that it includes the crust and the rigid mantle, the very upper part of the mantle, okay, is the lithosphere. Now, another part I want to take a look at right now is the moho. The moho is the boundary between the mantle and the crust. That is the boundary between the mantle and the crust. It was discovered by seismic waves. Okay, and then it was named after the scientist who discovered this boundary by analyzing seismic waves, Croatian, with the last name Mohovovcic. Okay, and I mispronounced that a little bit, but that's why they shorten it to Moho. Okay, it's called the Mohovovcic discontinuity, and I'm really not saying that very well. You can look it up in your book and then Google the pronunciation. So that kind of leads us into direct observations versus indirect observations. Direct observations include any observations made using any of the five senses, mostly our eyes. That's why I have a telescope in the background. And scientists mostly want to use direct observations because they're going to be the most accurate. Now, one direct observation we could make about the Earth, and that we do make with the Earth, are with drilling. And they have tried to drill through the crust to get to the mantle, but there just are many obstacles that have gotten in the way with that. Some things are lack of funding, broken drill bits, sick crew members, actually, and just poor technology. We've actually have just not been able to do it. So, in your book, if you want to read about that, there's a little bit about the history of that that you could take a look at. Now, indirect observations involve collecting data that is the result of something happening. Literally, we have not even barely scratched the surface of the Earth as far as direct observations go. So, what we know about the interior of the Earth is all due to indirect observations, like about the moho. And we use seismic waves to discover that. And seismic waves travel through the Earth. They're produced by earthquakes. They behave differently as they travel through different substances. And scientists look at the behavior of the waves to determine the substances of the Earth because they cannot examine the actual inner structure of the Earth directly. So they have to analyze the behavior of these waves. And we, in our class, took a look at a diagram of these waves that was in the book. And on the diagram, you could see how those waves bent as they went through different layers. They bent differently. And so by analyzing where those waves end up coming out and everything due to these bends, scientists can tell different things about the interior of the Earth. So, our objectives were to describe the separate sections of the mantle, including the asthenosphere. So, we saw that the mantle is pretty complex. There are different parts to it. Explain what convection currents are and how they are created due to that heating and density differences. Remember, as we go further towards the middle of the Earth, it becomes denser in the middle than it is on the outside. And to compare and contrast direct observations with indirect observations. So don't forget your 5 questions.